Hello. Let's see. Can everybody hear me? Can you see? Is it everything seem to be working? Do you hear me?
Yeah.
Yes,
Okay, great.
Professor.
All right, just make sure because it's hard to know if everything's working or not.
Looks
Okay.
good.
Okay, everybody's coming up. Most people are in by now. Okay, great. All right, let me switch to screen sharing. Okay. All right. So, okay, and okay, you should see the desktop by now. Okay. And here's, oh, I forgot to put the new reading assignment up here. So I can just tell you right now, see, the reading assignment for today was 2.1, 2.2, 2.3, 2.4. Okay, the reading assignment for next Tuesday is 2.5 and 2.6. So if you go over, I'll update this after class, but the reading assignment for today is 2.1, 2.2, 2.3, 2.4, and the next reading assignment would be 2.5 and 2.6, actually probably in 2.7 too. Those 2.5, 6, and 7. Okay. All right. Okay. So we want to talk about these sections here. Okay. 2.1 through 2.4. Now, let's see. Let's check. The homework assignment is due this evening. Okay. If you've got questions, okay. First of all, anybody got a question about the homework assignment? Before we go forward, it's due this evening around midnight. Anybody have a question about the homework assignment?
Does the so does the like heading at the top that we're supposed to put for any homework assignment, is that included in the character count?
Yes, remember you're sending me two different files. You're going to send me one called homework2.java. That one should be nice looking, properly formatted, indented, with your name and email address at the beginning. Then you also send me a homework2 short. That's the one where you can delete anything and everything that you can get away with. Yeah, and it doesn't have to be readable. Just to see how short it can be. But this one,
Yeah.
yes,
And
it
both
should
have to be under 600
it has to be under 600. Yeah.
for both?
Well, if this one's under 600 and then you delete all the spaces, so will this one.
Okay.
Yeah,
Yeah,
because
that
this
makes
is going to be
sense.
the short version of this one. Okay. So yeah, this one needs to be under 600, but it still has to be nice looking. Okay. So you won't do this in this one here, because this makes things unreadable. You're not supposed to, in real Java, you don't declare two variables on one line, but you're allowed to do that in this one to see how short you can make things. Okay. So like this is something you can do in the short version, but you shouldn't do it in the, what you might call the medium version. Okay. Right. So but you do need to have your name and email address in that version there.
For the short version, we don't need our name and email address header.
No. Yeah. And now let me download the zip file real quick and show you. Now in the zip file, I put, see this file here. That's what you fill in to create homework 2, right? So it's not done. You fill it in, okay? I did the same thing for the short version. It's you fill it in, but to give you a sense of what I mean by it's a short version, I already took out most of what doesn't need to be there. So what you fill in, if you look real carefully, is right there. That's where you fill in. So I took out, but see, the idea is that the short version, you can really take out anything that doesn't need to be there. So I already did that. I took out the stuff that doesn't need to be there. So for this one, you have to put your name up here, okay? And then you have to have proper indentation. So it has to be properly indented, okay? Then you put your code in here, but your code has to be properly indented. And you make things short by using variable names, not by taking out the indentation. You make things short by using variable names. But in this one, like I show you here, you can go ahead and just take out anything and everything that doesn't have to be there. So for example, the word public doesn't have to be there, so it's not there here. You don't even have to spell out args. So over here, I just use the letter R, okay? And your code goes between that pair of braces right there, because that pair of braces is this pair here. Your code goes between these two braces. In this super short version, that's those two braces there. So I gave this file is to give you the hint that, yeah, in this one it's okay to take out things that don't have to be there. Notice that you can't take out that space there, because then you end up with the word public start, which is all one word, and Java can't read that. That space has to be there. That space has to be there. That space has to be there, but there doesn't have to be any spaces here or here. No. So like that space has to be there, but you don't need a space after the word short. Okay. Okay. So I took out a lot of what doesn't need to be there already in this one. So this one, yeah, that's where your name will go. Everything should be nicely formatted. It should look like good Java, but it uses variable names to make things as short as possible. And then this one, you can just delete everything you can just to see how short you can really get it. Okay. All right. What about other questions about the homework assignment? Let me show you one trick. There's been a question that's come up a lot from people. So I think I should show everyone the answer, because it came up a lot, and the answer to it can be really useful. Okay, so I'll just put it in, well, let me put this in Dr. Java. So let me start Dr. Java. Dr. Java is very slow to start that time. Okay, and I'm going to open this one in Dr. Java. Now let me just show you an idea. If I have a string S and it holds hello, I can make a new string T out of S by saying S plus S plus S. Okay, then I could print T. Okay, now printing T is like printing hello 3 times. Okay, so that's the idea, that once you've given something a name, you can refer to it by name. Oh, I forgot, that's a mistake there. That's a T equals S plus S plus S. So T is hello, 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 and I don't have to spell out hello, hello, hello 3 times. Okay, now if I compile and run this, there's one little kind of quirk about this that I don't really like. Hello, hello, hello are all strung together. I really like, what I would really want, and what you're going to need is, like, for example, hello, hello to be on separate lines. So you can go down here. Now you could put S, you could do print line. Here's what you don't want to do. I don't want something like this. I don't want to print line S 3 times, because see, I'm typing an awful lot. If I don't want to do this 3 times, because it's so much typing, and we're trying to learn how to like make our programs more compact. See, that got me hello, hello, hello on 3 lines, but by awful lot of code. Turns out there's a much easier way to do that. So instead of this, here's a little trick I can do. I can put a new line in between those 2 S's. And I can put another new line between those S's. Now these S's are separated by a new line. Now this guy's going to print 3 lines. See? And now I didn't have to print line 3 times to get 3 lines. I could print line 1 time, but buried in him is new line, new line. Okay, and I can even make this a little bit better. Here I embedded the new lines inside of T. But if you notice that that's S followed by a new line, S followed by a new line, but that's repeated. So really what I want is the new line really could have been up here in S, and then I don't need it down here. Now, S plus S plus S, well, each S has a new line in it. Now this one line of code prints 3 lines real well, and there's nothing repeated. Notice I'm trying to avoid repeating something. So instead of having the /n's repeated here, I could move them into S, and they're not even repeated anymore. So then even the /n's are no longer repeated. So let me compile this and show you. So now, whoops, what did I do wrong here? Oh, I got 2 pluses in a row. I forgot to delete one of them. Okay. This is one of the tricks that'll help you save a lot of space in your program by embedding /n's into what you need a lot of variables, and some of your variables should have a /n in it. Not all of them, but some of them. And if you put the /n's in the right places in your variables, then you could do things like one print line can print lots of lines. Okay, so that's a real good trick to be using, to bury the /n into your variables. And let me just show you that if you go back to the reading assignment, here's back here in chapter 3, I think it was chapter 3. Let's see it. Oh no, I'm sorry. I think it was, I'm sorry, not chapter 3, it was back in chapter 2. I'm trying, now I forgot where it was. The book, I just wanted to show you that the book mentions this trick. And now I don't remember where the trick is. Oh, way back in chapter 1. Using escape sequences. Okay. See how they buried a /n into a single print, and then you run this and you get 2 lines of output. Okay. Now, here's what I'm showing you. Little ideas get buried. Programming is like this. There's lots of little ideas all over the place. Here's a little idea that the first time you read the book, you might not even notice that they even mentioned it. Okay. And I'll try to point these things out to you, but that's actually an important trick. Burying a /n in the middle of a string, putting it in the middle of something so that the string actually prints out on 2 lines. Okay, and we call this /n an escape sequence. So programming involves lots of little details like this. I'll try to point them out as we go along. So like right now, I was just showing you that now you can make use of that little detail by putting the /n into this variable here. You can now find a good use of this little detail that was back in chapter 1. But it's a detail that's easily kind of sliced by you because you're not really sure what it's there for at that point. And a lot of times when you're trying to learn to write programs, you have to go back and reread things, and then you start saying, hey, wait a minute, I can use that idea. An idea that didn't seem to be important when you first see it, then you might later on realize that you can go back and make use of it. And I'll try to point these out to you, like ideas that that we mentioned or were in the book, but it's not clear why you would need them. At some point, you'll find out where you can really make use of them. Okay, so putting escape sequences /n into one of your strings in one of your variables, this is now where you can make really good use of that. Okay, this trick will save you lots of space, because see how many, compare that one line to those 3 lines. Okay, so there's a lot, they do the same thing. Okay, if you compile this prints 3 hellos, and then each of these prints a single hello. So they do, the output looks exactly the same. Well, actually, no, the output didn't quite look exactly the same. Actually, what happened here? Why did I get blank line, blank line, blank line here? Can we see, how would I fix that? How do I make this one line do the same thing as these 3 lines? So we see, where did that blank line come from? Let's read the system.out.println s. What's in s? Hello/n. So that prints out the letters hello and then puts a new line after them. But that's in here. Now, what does println do after it's printed this? So let me see, what would println do after println has printed its message? What does it do?
Goes to a new line.
Go to the next, but we've already done that once here. So we end up with 2, it goes to the next line, the next line. So it skips over 1 line. So this actually prints out 2 lines. It prints out a hello, new line, that's part of the hello. Then the ln says go to a new line. Then hello with a built-in new line. Then the ln of println goes to a new line. Okay, so how do I get these 3 hellos next to each other without the blank line in between? How
Make
would
it
I
print
fix?
without the ln.
Pardon me?
Make it print without the ln. Just
Yeah, make it.
system
Now,
out
I
print.
could remove the /n from s, but
That too.
then this won't work. A better thing to do is to remove the ln from here, remove the ln from there. Compile, run, see? Print s. S has got its own ln built into it. So I printed hello, then hello has this new line built into it. But so that was print. Then print s. S goes over here and it's got a new line built into it. So it comes down here and that's print's finished. Then println s will actually print out hello. Hello's got an ln built into it, a new line built into it. And then I get a blank line because then I have the ln on print. So then I get this blank line and there's my new, there's where that's where the end of the output was. Okay. Right. Now, if I got rid of this ln and I got rid of this ln, now everything is going to be, there's not going to be any blank lines anywhere. Okay. So you notice there's no blank lines anywhere. Okay. But if I put the ln back there, I'll have a blank line between this output and the beginning of this output. If I put an ln here, I'll get a blank line between this output and that little arrow that comes up here. So now compile and run. Okay. As I'll keep pointing out a lot, programming is a lot of little details. The little, the ln or not the ln, the /n inside of hello or not the /n. Like if I take out the /n out of hello now, okay, this block was ended by that ln. And then this block was ended by that ln, but now there was nothing in between here to break up this, and this, because I took the ln out of the hello. Okay, so I really want the ln in the hello. That'll look the best. Put the ln in hello, and then an ln here to break up this block from this block. Okay, and the ln here is really not that important because there's nothing coming after this block. After this block was just that arrow there. So I really don't really even care what comes after that block. So if I compile it now, okay, a block of 3 hellos, a block of 3 hellos with a blank line in between. Notice that that blank line's got nothing to do with this blank line. This blank line is just there to make it easier for me to see that I'm printing, I'm doing one output and then another group of outputs. That black line, that blank line has nothing to do with the output here. So if I compile and run it again, see, the blank line there was just to make it maybe for me to think that, okay, actually I should have a blank line there and a blank line there. I'm setting up my variables, then I'm printing them once and printing them as a second time. This prints the first, this sets up my variables. So it's a little block of code setting up my variables. Then I use my variable here to print out one block of hellos. Then I use my variables here to print out a second block of hellos. When we write code, we use blank lines in the code to try to decide, to organize the code into groups of code. Like this group of code sets up the variables. This group of code prints the first block of hellos. This block of code prints the second block of hellos. That's a lot easier for someone to see. If somebody looks at that, they think you're somehow doing 3 things. You've got a block of code here, a block of code here, and a block of code here. So somehow you're doing 3 things. And the 3 things are define my variables, print out hello, 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 hello once, then print out hello, hello a second time. If I write my code like this, it makes it harder for people to figure out what I'm doing. It kind of looks like I'm doing one thing when I'm really doing 3 things. Declaring my variables, printing them out once, printing them out a second time. So when you format a Java program nicely, you try to think, okay, how do I want people to understand my code? There's a chunk of code here that does one thing, a chunk of code there that does another thing, and a chunk of code here that does a third thing. So that would be the way I would space out the code, but that spacing of the code's got nothing to do with the way the spacing of the output is. Okay, so remember, put a /n in some of your variables. That can help save a lot of space. You can just type, one line of code here can replace a bunch of lines of code here. So that is a clue that can be real useful in getting your program shorter. Okay. All right. Any questions about this? Okay. Any question about this trick, or about any other question about from the homework assignment? Okay. If you have questions, send me emails. The assignment's due at midnight tonight, and remember, you're sending me 2 files. The homework 2, which is readable but short, much shorter than the long one, and then homework 2 short, which is the unreadable one, where you can just really get rid of anything and everything that doesn't have to be there. And in the homework 2 short, you could, for example, do that. You don't need to say string 2 times. And you could do that. You don't need those spaces, and you don't need those spaces, and you don't need that space, and you don't need that space, you don't need that space, and you don't need that space, and you don't need that space, but you certainly need that space, because string A is not a meaning, string S doesn't, strings, that word doesn't mean anything to Java, so you need that space. Okay, so in the short one, you could do things like that. And then you could even then go over here, and you could say, this still compiles, and this still runs fine, starting to become very unreadable, but that's okay. For the short one, just see what Java will let you do to get things short. Okay. Right. So that's what you can do in the short one. But the one you turn in should look like this, nicely formatted. Every variable on its own line. You should put spaces around pluses. You should put spaces around equals, because those are the rules that we use for real Java programming. You don't have to put these blank lines in there if you don't want, because your code, you won't have that much code. So, but the blank lines actually don't take up space. Here's something useful to remember. That takes up space in my program. There's those spaces are in my program. If I want to make sure my program is as small as possible, I would actually make sure that I don't have any spaces on a blank line. Okay, that's a little thing you could check for, is you don't want to have spaces on your blank lines, but you can easily solve that by not having blank lines. Okay, it's okay in your short program to not have any blank lines, but you do have to have things properly indented. Have operator, equal sign has a space around it, plus has a space around it. I don't care whether you put blank lines or not. You do have to have indenting. You have to have the indenting in there. But with these by using variables well, it's easy to get under 600 characters if you've defined enough variables. And you use this trick of the /n. If you combine this /n trick with enough variables, it's not hard to get under 600 characters and still have your name up here, all this indenting. String for every variable should be declared on its own line, and nice spacing, nice and readable. Okay. Any last question about the homework?
Professor,
Uh-huh.
if I already submit my homework and I want to make it a change, should I resubmit it?
Yeah, sure. Yeah, I don't. Yeah, Brightspace doesn't care, and I don't care. I'll just download the most recent version you upload.
Okay. Gotcha.
And so as long as it's on time, and even if it's late, if you think you really could make something a little bit nicer, go ahead and upload it even if it's late. If you've got it uploaded on time, then you think, oh, I can make it better. I don't mind if you upload an improved version late, as long as especially if you've got especially if you're just improving things, making things a little bit nicer, or if you ask me a question, I give you an answer, and you can use the answer after it's a little bit late. It's okay. Your real goal is to write good homework problems. Your real goal is to get good programs written, because that's what you learn from, is by having good, well-written programs. So if you can make an improvement and it's late, it's okay with me. Now, if you make the improvement 6 weeks from now, it's not going to count. It's not going to count if you make the improvement after they've been graded. But if you make the improvement, like the next day, if you make the improvement soon enough, it's okay. Brightspace will let you upload things late. Okay, so you are allowed to upload things late, and you're allowed to upload things more than once. And I see all the versions you uploaded, and I can download any one I want. If I don't want to download a late one, I can download the early one, though I usually don't care. And I usually will download the last one you upload up to when I do the grading. I won't go back and download them after they've been graded unless you have a special question or something about something. Okay. All right. So, but especially now they have, especially if they're not due yet, certainly if you've come up with a better idea, go ahead and fix it and upload it again. Okay. All right. Any other questions about the homework? Okay. Okay. So keep this hint in mind. If you haven't used this trick, please consider putting it into your code. All right. So let's go to the current reading. Okay.
Wait, is doing that going to get us prepared to be more familiar with scripting?
Well, doing what? When you said doing that, what do you mean? Doing which thing?
getting rid of all the unnecessary spacing.
No, it doesn't get you ready for anything. No, the unnecessary spaces just gives you a sense of what Java's requiring and what Java's not requiring.
Okay.
It's a trick. Um, it's used. The only people who actually use the idea of getting rid of all the spaces are JavaScript people. JavaScript.
Yeah, that's what I'm talking about. Is JavaScript scripting and
No,
isn't
well, when you use the word
Java
scripting,
programming?
no, okay, first of all, when you use the word scripting, there's lots of scripting languages. Python, Ruby, JavaScript. So there's lots of scripting languages. And most of them don't do what JavaScript does. So the only language that does that is, and in the case of JavaScript, you only do that after your code has all been written and you're ready to distribute it. And it's actually a failing of the JavaScript language. The fact that you have to do that to JavaScript programs, to take them and delete all the spaces in them, is actually an aggravating, silly failing of the JavaScript language. And eventually, so it's not this trick of shortening a program. This trick of shortening a program by getting rid of all the spaces. JavaScript people, they actually don't do it by hand. They have programs that do it for them. Let me show you. Okay, JavaScript calls it minifying. Okay. There's my code. Minify it. Oh, they don't like my code. I think this one only minifies JavaScript. Let me find one that'll minify anything. Oh, this one doesn't like my Java. I remember I found one the other day that doesn't, which will minify anything. See if I can't remember where it was. There. Notice that they do it automatically for you. They got these programs, they're minifying it. See, it did it automatically. It just deleted all the spaces. The only people in the world who need to do this are JavaScript people. And it's a dumb feature of JavaScript. And so this idea is not getting you ready for doing JavaScript, because this is actually not even a good feature of JavaScript. It's just the necessary evil of the JavaScript language. And you don't do it by hand. You just use one of these minifying tools. Yeah. The other ones I tried just required it to be JavaScript. This one's a little bit smarter. It just can minify anything. Notice how it took away, notice how it left that space? And it left that, it was smart. It knew what to remove. And oh, actually, it didn't do real smart. It could have got rid of that space there. So their minifier missed one space that could have been gotten rid of. Oh, and it could have got rid of that space there and that space there. So it did almost as much minifying as possible. Could have done a little bit more. Okay, so JavaScript is the only language that needs this. They call it minifying, for making things minimal. Okay, so they call it, and you can see how there's a gazillion things that'll minify for you. Okay, but so here I'm just having you do it as more of an exercise in trying to see what JavaScript forces on you and what what Java forces on you and what it doesn't. Like, it does not force on you the indentation. Okay, it does force that space there, because without that space, it can't tell where the word string ends. It doesn't know the difference between string and strings. Okay, so it's really an issue of just what does Java require and what makes things look good versus what is required. The JavaScript language, everybody writes their code like this because they want it readable. But in the JavaScript world, after they've made their code readable, then they go and they minify it. They minify it and make it unreadable. And then that's what gets distributed over the internet. What gets distributed over the internet is the minified version of your JavaScript programs. Okay. And it's only for distribution over the internet that you do this. Okay. And it causes all kinds of grief. It's actually, it's not a good idea. It's just a kind of a unintended consequence of the way JavaScript was designed. It can cause bugs. It can cause, it's not a great thing. It's just, we're stuck with this in the world of JavaScript. Okay. All right. So the minifying that you're doing in this homework assignment is more for fun. You know, it's more just to see what will Java let you get away with in terms of making a program shorter. What will Java let you do? Okay. There are people who do this for fun. In the C programming language, there's something called obfuscated C. The word obfuscate means to hide or to make unclear. C programmers for years have thought it was clever to make their programs unreadable. So let's see, let me show you an example, if I can find a good example. Oh, I'm trying to remember. It's a contest to see who can make their program more unreadable. Let me see if I can find a good example. That's a C program. It's a picture of a C program that's been obfuscated and laid out in a bizarre way, but that program compiles and runs and draws a picture that looks just like this thing here. The program, when it runs, draws a picture that looks just like the program. And it's a picture of something in math called the Mandelbrot set. It's a famous example of an obfuscated C program where they've made the C program, the shape of the program looks like the thing it draws a picture of. And C programmers have done this for years. It's a game they play of how much can they make their program hard to read and make the shape of the program somehow a joke or a pun, or make the shape of the code somehow a reference to what the code does. Okay. So they have the International Obfuscated C Programming Contest. The International Obfuscated C Programming Contest is where people literally compete to see who can write the most obfuscated, bizarre C code. Okay, and the code ends up looking a lot like minified JavaScript, but this is done purely for fun. Okay, I wish I could find a real good example here. I used to remember where there was some good examples. Okay, there's a C program. It's just a block. He didn't make it pretty in the sense of making it have a nice shape, but that program will compile and run and do something interesting. Sometimes these programs will play a game. Sometimes they draw a picture. Like that, see, that's his C code. And yeah, that's his C. Yeah, I'm not sure what that program does. I'd have to download it and compile it and run it. But you can see that he's made the code somehow represent an image that has something to do with what the program does. Okay. So there's programmers are weird. Programmers sometimes have fun doing weird, strange things. You can, if you look, you can kind of read that that's code, but here he's gotten rid of spaces or added spaces to give shape to the code just for fun, just purely to make things weird. and he won the contest. I mean, he's up here because he's one of the winners of the contest. So the judges liked what he did here. Okay, so oh, that one doesn't open. Here's another one. See, somehow there's the code is kind of a picture, and when you run the code, what the code does will have something to do with what that picture is a picture of. Looks kind of like a letter Q but I'm not sure what this is up here. I'm not really sure what that's supposed to be a picture of, but somehow when the program runs, it'll mimic that picture somehow in some way. Okay, so what we're doing is really it's just kind of a game. It is kind of a game that programmers play, except for the minifying. The minifying of JavaScript is not a game. It's something that you kind of need to do with JavaScript. Get rid of all the spacing in JavaScript programs to make them easier to distribute over the internet. Okay, so now let's start going to the reading of this today's reading assignment. Okay, so we're going to start talking about objects. We were talking about methods. We did a bunch of stuff with methods the other day. So here's one of the examples we did. Remember, we defined a method. A method is a name for a block of code. Okay, so when you use that name, you're really using it as a replacement for that block of code. So when you call 3 lines here, you get those 3 lines. Okay, so a method name is a name for a block of code, whereas a variable name is a name for data, like a string. A method name is a name for a block of code. And then you can do interesting things like you can give your blocks of code parameters. See, you can give your block of code, see, here's 3 lines, but 3 lines gets a greeting, and instead of printing a blank line, it now prints that greeting on each line. Whereas the original version, 3 lines just printed 3 blank lines. Now the 3 lines takes a parameter and it'll print that parameter on each line. Okay, so 3 lines represents this block of code, and 3 lines takes in a parameter that we use in the block of code. Okay, so we've said that this block of code should do something, but it should do something with this parameter. Okay, all right, so so that's a real fast review of what we meant by methods. And we're going to be using methods all semester long. We're going to be constantly talking about and thinking about and learning more details about methods the whole semester, because it's one of the key ideas of the course. But now we want to go to something called objects, okay? And then objects and methods are going to get combined into one idea. So see, when you get to section 2.3, calling object methods. Okay, so we'll combine these 2 ideas. In fact, we'll see real quick that objects and methods kind of come together in pair. The word object and method, you almost always use them at the same time. Okay, so here's an idea that's going to come up a lot in programming. Programs want to represent things in the real world. If you're a company, you have a database, and your database will have, for example, in it all your employees. So you want a way in programming to represent the idea of an employee. Now, an employee is a bundle of information. The employee's got a name, he's got a department he works in, the employee has a salary, the employee has a boss, the employee may have underlings who work under the employee. So there's all this information that you'd want to store about an employee, maybe their home address. Okay, all the information you might store about something is what we mean by an object. When you take something like an employee and you store for that employee the value of that employee's name, the value of that employee's salary, the value of that employee's department. When you store all those values, you're storing what we think of as an object that represents that employee. Okay. A real simple example of an object that we've been using are strings. Okay, if we go back to the little code we wrote just a little while ago, we were playing with strings. In the Java language, strings are objects. I'm starting up Dr. Java. Takes a little while. A string is actually an object because it holds information. That string holds the individual letters HELLO/N. Okay, so that's an object that holds information. The information it holds is what letters do I represent? Okay, now an employee object holds a lot more than just a few letters. An employee object would hold some strings like name and address. It would hold some integers like salary and social security number. You know, it would hold all kinds of pieces of information. And we're going to learn how you bundle information together. But in Java, a string is a simple example of an object. And what it bundles is the letters that are in the string. Okay, so we've already seen an example of an object, it's string. And another example we've seen in an object is scanner. We talked a little bit last week about using a scanner to read input from a user. And we'll see that a scanner is another example of an object. Where was the scanner? Real quick. Here's where you tell Java to create what you might call a scanner object. The scanner objects are bundles of information. This scanner object is going to be two pieces of information, where it's getting its input from, and then whatever somebody types into the keyboard will get stored in that object. We'll go back to this example over and over again. But scanner is an object. It holds data. The data it holds is, first of all, where it gets its information from. And then when you create the scanner object, whatever I type over here, that's going to get put into the scanner object. When I hit enter, the stuff I type over here becomes data in the scanner object. Okay? That's what happens when I see the scanner object's called in. When I call next line, the data I type in here will get moved into the scanner object. Okay, so the scanner holds data. What it holds is the stuff you type at a command prompt. Okay, this is tricky ideas, and we're going to keep going over them and over them and over again. But the key idea is that an object holds data. Okay, and depending on what the object's representing, it holds different kinds of data. An employee object would hold stuff about an employee: name, address, social security number, salary, how many years, what was the start date of their employment, all kinds of data like that would be stored in an employee object. A string object is simple. It just holds the letters of the string. A scanner object is more complicated. A scanner object holds the data that you type in from the keyboard. Okay. Now, the book here uses an interesting example of an object. It's actually a lot of books use this example, something called a turtle. Okay. This idea of using a turtle object it's been around for a long time. Now, this is not a real turtle. A real turtle would store things like its internal organs. What the idea is here, let me just show you. The turtle is meant to be something that represents drawing on a piece of paper. Okay, so here's what happened. Let me just run this program. There's the turtle. The turtle is something that we think of as allowing us to draw on a piece of paper. So the turtle has got a pen buried in his stomach. And when the turtle crawls, the pen draws across the screen. And the turtle can turn and face different directions. So initially the turtle was down here facing that way. When he crawled, he drew that line. That would be this line here that says the turtle should move forward. that took the turtle and moved him this way. Then the turtle was told to turn left, so he was facing that way. Then he went forward and drew this line, and now the turtle's over here. The turtle is an object. So here we have this idea that we have a new turtle object. Okay? You create objects with something called a constructor. So this is what we call a constructor call. It created a turtle object. Okay. Now, before we can create a turtle, we have to create a world that the turtle can work in. Okay. Now, the world has a size to it. That's the size of the screen that we want the turtle to play on. So, for example, if I make this 100, 100, I can get myself a turtle that's working in a very small world. Okay. Now my turtle lives in a very small world. Okay. If I make this 500 by 500, I'll get a turtle living in a larger world. Now what I've got here is a world object that represents the world the turtle lives in. The world object stores data. It stores its size, and it turns out it's also going to store the turtles. The turtles will live. See, when I create the turtle, I say, oh, I want a new turtle in this world. Okay, this is the way and this is the way they designed this to work. Is you create a world and you give it a name. See, this creates the world, but then to be able to use it, I need to give it a name. So I call it world. Not a very creative name. Notice that here, this is lowercase because it's a variable. This is uppercase because it's an object. It's the name of an object. I'm creating a world object and calling it world. Okay. So this then are now these are parameters. Just like we have methods take parameters, these are parameters to the world constructor. So this is a constructor. It builds the world. This is a constructor that builds the turtle. Okay. Down here, these are methods. This is a method on the turtle. Okay. Now, we said that an object holds data. Turns out that objects hold more than data. Objects also hold methods. An object is a thing that holds data and methods, and the methods act on the data. The methods manipulate the data in this object here. So this is an object holding some data. We'll talk a minute about what data would actually be in a turtle. Okay, we'll see in a minute, like what data is in a turtle. This method manipulates the data in that turtle. And this method manipulates the data in that turtle. This method doesn't seem to take any parameters, but actually it can. So for example, if I put a 50 here, that meant right now the turtle's going forward a set amount. I forget what the set amount is, but here I'm saying I want him to go forward 50 units. So instead of going forward the set amount, I want him to go forward exactly what they call 50 units. Okay, well, that looked about the same as it was before. So let me make this just, I'll make it 100 units. Make it 200. Their units are really little. There's 200. See, there was twice as many units. Their units are actually kind of small. The steps are very small steps. So that's 200 steps forward, turn left. There's no parameter there. That turned left 90 degrees. And then this forward was the default mount. I forget how many steps that is. Maybe that's about 100 steps. Okay, so I could either say how many steps to move forward, like let me change this to just 10 steps forward. That should be a very small little movement forward. Okay, the turtle moved forward 100 steps. turn left 90 degrees, and then move forward just 10 steps. So there wasn't he just moved forward a tiny bit there. Okay. If I move him forward 200 steps, then he'll go 200 steps, turn left, and 200 steps. Okay, now here's the ideas I have so far. I have a turtle object that holds data. On that turtle object, I can call a method, which is a bundle of information. I'm sorry, a bundle of instructions. Those are the instructions that tell the turtle how to move. That method took a parameter that said how much to move by. Now, somebody wrote that method. Later on, we can actually look at the code for it. If you, on this page, it won't help you very much now, but the author lets you download the code for this turtle, but you won't be able to read it yet. You know, it won't be till the end of the semester that you'll be able to read that code. But the thing is, if you download that code, you can use it in Dr. Java, for example. So we might do that. We might download, I'll have you, later on, we'll practice with this stuff, but we can download their code and we can use it in Dr. Java, but we won't read it in Dr. Java. We'll just use it like we're using it here. But they wrote a method called forward, and what it does is it manipulates the data in this turtle to represent the data that the turtle's moved 200 steps. Okay. Now, so a turtle is an object, and he stores data and methods. And then you can call these methods on the object, and each time you call a method on the object, it updates the data in the object. Okay, now let me show you some other things you can do with a turtle. Okay. The turtle's got a pen buried in his stomach, and the pen has a color to it. And the pen is what we say down right now. When we say the pen is down, that means the pen is drawing as the turtle moves. I can tell Yertle to raise its pen. Now, the pen is one of the pieces of data in the turtle object. When I say pen up, that turtle changes its data in itself to represent the fact that the pen is not touching the ground. If the pen's not touching the ground, when he moves from here to here, there won't be a line drawn. So now run this. Whoop.
You spelled Yertle wrong.
Pardon me?
You spelled Yertle wrong
Oh, I spelled Yertle wrong?
on the third one.
Oh, yeah. Yeah. Now, after he turned left, he raised his pen. So then he moved over here and didn't draw anything. So the state of the pen, whether it's up or down, is an example of a piece of data that this turtle holds inside of himself. So he remembers whether his pen is up or down. Okay. Now he also remembers what the color of his pen is. So now, when he gets over to, at this point, I'm going to tell him to put the pen down. And I'm going to tell Yertle to change the color of the pen. Let me see. I think it's pen color. Okay. See if this works. Oh, and then I want him to, the turtle will go up, turn left, go over, raise his pen, go over. Now I want him to tell the turtle to turn left again. And go forward now. One, 200. But it should go forward drawing a blue line at this point. Okay, so one of the things that the turtle stores inside of him is whether his pen is up or down. Another thing that the turtle stores inside of himself is what the current color of the pen is. Oh, let's see. You have to use a funny name. I think I have to use this funny name for color. Oh, I forgot what they called the pen. Oh, I forgot what I forgot what method they used to change the pen color. I looked it up.
I think
Pardon me?
it's set color.
Pardon me?
I think it's set color, SET color.
Oh yeah, let me try that. That may be right. It might be set color. I looked it up earlier today and then I forgot. Let's see if it's set color. Oh yeah, it was set color. Okay. All right. So the turtle, he has a lot of data in him. So we now know that the data, one of the data things in him is whether the pen is up or down. Another data thing in him is what's the color of his pen. Now, what are some of the other things that the turtle knows? The turtle knows where he is. So the turtle keeps track of what the XY coordinates of where he is. Okay. The turtle actually, the other thing you could do is see how this line he draws, you can change how wide that line is. You could tell the turtle to draw a thick line or a thin line. The turtle remembers all kinds of things about himself. And then there are methods for updating that. Oh, another thing the turtle remembers is what direction he's pointed in. Okay, so for example, now there's a more, I can turn the turtle, instead of saying turn left, turn right, I can tell the turtle just to turn. But if I tell him to turn, I give an angle. Like here it says turn 45 degrees. Okay, so now I'm telling the turtle to turn 45 degrees. So the turtle remembers what direction he's headed in, and turn left, turn right, just always turn it by 90 degrees, but you can just say turn an arbitrary number of degrees. So that's updating what the turtle remembers about its direction. So turn left 90 degrees, turn left 90 degrees, now turn 45 degrees. So see, he's pointing at an angle. I told him to turn 45 degrees. Okay, so the turtle remembers what the data inside of a turtle that you can change with these methods are where he is, what direction the turtle's pointing in, what color the turtle's pen is, whether the turtle's pen is up or down. Okay, now you can also create more than one turtle. So let me create another variable. I'm tired of typing Yertle, so I'll just call it Y2. Y2 is my second turtle. My second turtle in this world. So I'm going to create a second turtle in this world. Okay. Now I didn't tell that second turtle to do anything, so it's just sitting there. His location is at if there's an XY coordinate system in here. Notice that the turtle's at the middle of the square. That's the origin with coordinates 0, 0. So he's sitting there. I haven't told him what to do yet. So he's just sitting there. I could tell that turtle to be, one of the things the turtle knows is whether he's visible or invisible. So down here, I'll say Y2 dot, oh, I don't remember how you turn them invisible now. A turtle can be told to become invisible. Well, I don't remember the command for how to turn them invisible. I don't remember if it's in, I don't think it's invisible. I don't think you do something like this to make him invisible. I think you, let's see. See, there is no invisible. Oh, well, first of all, I have to put a semicolon at the end of that. There is no invisible. There might be something like set visible to be false. It might be that. You say set whether he's gonna remember whether he's visible or not. And I want to change whether he's visible or not. So I want to say that, well, visible or invisible is example of a Boolean. It's either true he's visible or false that he's visible. So this might work. Yeah, it worked. Now notice he's visible. Oh, he's still visible. Didn't have any effect. Okay, I'll have to go back and look. Yeah, I thought that was the way they changed whether he was visible or invisible. It worked. I mean, it didn't
Maybe
cause an error.
visible is a thing and it's just not completed yet.
Pardon me?
Maybe visible, the Boolean thing is a thing. It's just not completed yet, perhaps.
It might be that they didn't actually write this. Maybe they didn't finish this method. I don't know if yeah. Could try putting true here. That would make sense. That would change anything. Yeah, that's funny. So it worked, but it didn't do anything. I have to go and look at their code to see why that didn't do anything. In other people's turtles, if you set visible false, the turtle becomes invisible. But not the turtles are used in a lot of people's code. So there are Python turtles and Java turtles all over the place. It's a nice way to explain the idea of object-oriented programming. And most people's turtles work in a very similar way. Usually you set visible false to make the turtle invisible, but theirs isn't quite working that way. That turtle's still there, okay? All right, so turtles remember whether they're visible or not, okay? Now, I could, instead of making him invisible, I could just make that turtle do something else. I could make him turn right, make that turtle turn right, and then make that turtle move forward. I'm gonna make him move forward a lot. Notice I made him move forward 3,000. When he hit the wall, he stopped. See, the turtle actually didn't move forward 3,000. It's kind of interesting. When he got to the edge of the world, the turtle just stopped. 3,000 would have taken him way off the edge of the world, and he stopped when he hit the edge of the world. Okay. All right. So what we're doing is what we call this object-oriented programming. I'm programming by creating an object and then manipulating the object by sending it commands, which are method calls. I'm sending the Yertle the command to up its pen. I'm sending Yertle the command to move forward 200 units. I'm sending Yertle the command to move its pen down. Sending Yertle the command to change the color of its pen. Okay. Now, right now, we didn't write any of these methods. Later on, we'll write our own. We didn't write this object, and we didn't write these methods. We're using them. And that's actually a lot of programming. The majority of programming that programmers write is using objects that other people wrote. You use objects that other people wrote, and you learn how to send commands to the objects that they wrote. That's a large chunk of computer programming. In languages like Java and Python and Java, Python, and JavaScript are all object-oriented programming languages. They all use this idea of creating objects, then sending commands to the object. The commands are methods, just like we talked about the other day. The commands really are methods, though a lot of times people don't even think of them that way. They just think of them as commands. I'm commanding Yertle to move forward 200 units. I'm commanding Yertle to pull up its pen. So they actually are method calls with parameters, but people tend to sometimes just think of them as sending commands. Another phrase people use is sending a message to the object. So you'll see this, or if you read about programming, you'll hear people say that I sent the forward message to Yertle, telling Yertle to move forward 200 steps. I sent the pen down message to Yertle. I sent the set color message to Yertle. So with that color as the new color. Okay. All right. So this is a style of programming that's become very popular. Python, JavaScript, Java are object-oriented languages. We tend to orientate or organize our code around objects and messages we send to the objects. The objects are where we bundle data together. Okay, this world object remembers how big it is, and it actually remembers also how many turtles are in it. So that world object knows it's got 2 turtles in it because we put that turtle in the world, we put that turtle in the world. I don't know what happens if you create 2 worlds. I don't know. I don't think you're going to get 2 screens down here. We could give it a shot. You know, what happens if we create a second world? Sometimes things like that work and sometimes they don't work. Let's create a world 2. Let's make it a small world. Okay. Now, worlds don't show up until you show them. So you won't see a world until after you show it. So let me see what happens if I show world 1 and world 2. Okay. So now I've actually created 2 world objects, a big one and a little one. And I've tried to show 2 world. Now I didn't put any turtles in the second world object because there's no, if it won't work, there's no point trying to put a turtle in it. Try running this. Ah, look, I got a little world down here. I actually did get 2 worlds. Let me go ahead and put a turtle in the other world. So I'll call this I have a turtle. I'll call it Y3. Now this is a very strange thing to type. Y3 is going to be the turtle's name. So this is the name of a turtle. Now on the right-hand side, I want to create a new turtle. So I write, but notice how funny that reads. Turtle Y3 is new turtle. Okay. And this turtle is going to go in world 2. I'm creating a new turtle and he's going to be put in world 2. So world 2 is going to remember this turtle exists, and I'm giving that turtle that name. And I'm not going to give any commands to that turtle. I just want to see if he shows up in, see, this is another world down here. So let's run it. Something went wrong. I didn't get a turtle down here. Maybe, yeah, I'm not sure if this thing's really set up to show 2. I did get a second world, but no turtle showed up in him. So I'm not really sure why no turtle showed up in that second world. Object-oriented programming is like this. You play around with objects. I'm just trying an experiment. I was just curious to say, did these people even set up their web page to work well with 2 worlds? It might be it just doesn't work well with 2 worlds. Or maybe I'm missing something where I'm not getting that turtle to show up in the second world. Okay. Now, as you go on this page, there's just more examples of playing around with turtles like this. Okay. Here's an example where they built 2 different turtles. So here's their example where they created a world with 2 turtles. Okay. So they've got 2 turtles in their world, and each turtle was told to go forward. Well, one turtle was told to go forward, turn left, forward. The other turtle was said turn right and then move forward. So one turtle, they start pointing north. So it went north, then it turned left, which pointed it west, and then it went forward, so it went west. This turtle started out pointing north, turned right, makes him point east, and then he went forward in the east direction. Okay, and by default, the turtles come up with different colors. Notice that the second turtle was given a default color different than the first turtle. You can change the turtle's colors, but when you create more than one turtle, the new turtles get a different color than the previous turtles. Okay. Now, we're going to keep doing this. We're going to learn more and more different kinds of objects we can create and what we can do with those objects. So for example, I said a while ago that a string is an object. We'll learn what we can do with strings. Let me just show you one little thing here. String dot to you can tell a string to change itself from lowercase to uppercase. I'm calling a method on that string, and see the string converted itself from lowercase to uppercase. That's a method I can call on a string. It turns the string from lowercase to uppercase. There's a toLowercase method too, and there's some other we'll learn a bunch of different methods that you can call on strings. So we'll start doing things like a string is an object. Like I said, it stores these letters, and then it stores these letters, and you could call a method on a string and have it manipulate its data. So we'll learn methods that we can call on strings. And in the book, that was one of the later chapters. See, string methods, section 2.7. That's going to be your reading for next week, sections 2.5, 6, and 7. So there's a bunch of methods you can call on strings or objects, and you can call methods on strings. And they're very useful. That's how people work with strings in the Java language. Almost anytime you need to work with strings in the Java language, you use methods on string objects to edit the strings and do interesting things with strings. Okay, so that's going to be the style of programming we're going to be making use of. And eventually we'll learn to write our own objects and our own methods. But right now, we're going to spend some time learning to use objects and methods. Okay, so we run out of time. Anybody have any question? Any last minute question about this stuff here? Okay.
I got one.
Okay.
For the homework. So when we finish our to Java and then short Java, and then we highlight it and make it into a zip file, like, are those the only two things that we're highlighting?
Yes, you only send me those two things. Send me homework 2 and homework 2 short. Yeah. If you send me more, I just delete it. It doesn't really bother me, but I'm asking you to send me the homework. You have to send me homework 2 Java and homework 2 short Java. That's required. Okay.
All right.
Now, and the best, yeah, the easiest thing is just send me just those two things in the zip file. Okay.
Yep.
Any other questions about homework or what we talked about today? Anything to play around with? Okay. If you have questions about this stuff, the nice thing about this book is how you can run their code while you're reading the book. You can play around with their ideas. So do that. Play around with their ideas. They even say that themselves someplace in there. They want you to play around. They want you to try different things with these turtles. Try to get used to the idea that you're manipulating a turtle object. Okay, so I'll go ahead and I'm going to stop sharing now, and then we'll meet again on Tuesday. Any questions in the meantime, please send me an email. See you on Tuesday. Bye.